Okay, now let me go for the next question. A two-dimensional incompressible frictionless flow field is given by u is equal to xi dot minus yi dot, okay? J dot. If the rho is the density of the fluid, the expression of pressure gradient vector at any point in the flow field is given as option A, rho xi vector minus yj vector, B minus rho under bracket x square I plus y square j, C rho under bracket xi plus yj, option D minus rho under bracket xi plus yj. Okay, so now let me go for the solution of this equation. Okay, now let me go for the solution of this equation. What is your velocity vector is given to you here? U vector is equal to xi plus minus yj is given to you. Okay, and what you have to find out, that is your pressure gradient vector at any point. Okay, so what is your Euler's equation of motion? Euler's equation of motion, which is nothing but del u by del t plus u del u by del x plus v del u by del y plus w del u by del z is equal to fx minus 1 by rho del p by del x. Okay, fx most of the time generally equal to 0 when there is a no external force is applied. Okay, and this equation in the y direction. Okay, so del v by, okay, that is your velocity vector. Generally it is given in this format. It will be your u and that will be your v. Okay, but now they have given in the u vector. Okay, so del u del v in y direction, x direction, and now in y direction. Okay, del v by del t plus v del v by del x plus v del v by del y plus w del v by del z is equal to fy minus 1 by rho del p by del x. Fy generally equal to 0 when there is a no mention of the external force. Okay, and what is your rate of change of momentum? Okay, that equation we have written. Okay, at a particular point, that is nothing but that is your pressure. Okay, so let me go for del u by del t. Okay, del u by del t, what will get? 0. Okay, and u is nothing, u is equal to x and v is equal to y. Okay, u is equal to x and del u by del x is equal to 1. Okay, simply write down, calculate this thing. Okay, v is equal to minus y and del u by del y is equal to again minus 1. Okay, del u by del y is equal to again minus 1. Are you getting this or not? Yes or no? Means del u by, okay, just a minute. Okay, v is minus 1 and del u by del y 0. Okay, plus again w is 0, this equal to 0, 1 by rho del p by del x. Okay, so this term will be again equal to 0. So what will get? Pressure gradient in x direction is nothing but minus of rho x. Yes or no? Minus of rho x. Easy. Now let me go for the del v, means in the y direction. Okay, so v is equal to y. Here it will become 0. Okay, so v is equal to minus y. Okay, v is equal to minus y and del v by del x, it will become 0. Okay, so then minus v minus y plus del v by del y equal to minus 1. Okay, is equal to minus 1. This term will be equal to 0 only. Okay, so 0 plus 0 minus 1 by rho del p by del p by del y. Okay, so from here this will become minus, so what will get? Del p by del y is equal to rho y minus of rho y, okay, and pressure vector is nothing but del p by del x I plus del p by del y j, okay, yes or no? So from here we can go for means minus rho x minus rho y, yes or no, minus rho x I minus rho y j. So let we take rho common, my rho let we take rho common here, okay, so rho let we take rho common here, xi plus yj, okay, xi plus yj, that is your pressure vector, that is your pressure vector, pressure gradient vector, okay. So thank you for now. After this we will go for the next question, okay. Thank you. So next question, water enters a circular pipe of length L is equal to 5 meter, okay, and diameter 0.2 meter with Reynolds number 500. The velocity profile at the inlet of the pipe is uniform while it is parabolic at the exit. The Reynolds number at the exit of the pipe, okay. So let me draw simple schematic. Length of the pipeline is given, length of the pipeline is given to you, okay, length of the pipeline is given to you, okay, and what is the length is 5 meter, okay, this length is equal to 5 meter, okay, this length is equal to 5 meter, and diameter is given to you, that is your 0.20 meter. Here while entering in the pipeline it is having uniform velocity, while leaving it is having velocity profile as a parabolic velocity profile. These things are given, but there is a no convergence and divergence is given, okay, means there is no convergence and divergence is given, okay. So Reynolds number for the pipe is nothing but rho vd by mu, okay. Generally mu and rho are constant, velocity and diameters are variable, okay, but velocity variation will be not there because it is the constant diameter pipe, okay. So what you will get Reynolds number again, it is nothing but 500, okay. Velocity variation is not there, okay, means velocity increment is not there, okay. So it will be your Reynolds number will be equal to 500 only, okay. Thank you. Okay, now let me go for the next question. An idealized centrifugal pump blade outer radius is 50 mm. Okay, radius is given. Okay, consumes 2 kilowatt power while running at 3000 rpm. The entry of the fluid into the pump is axial and exit from the pump is radial with respect to the impeller. Okay, if the losses are neglected, then the mass flow rate of the liquid through the pump is dash 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 kilogram per second, okay, dash 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 kilogram per second, okay. So now let me go for the solution of this question. Before that, what we have to go for? Velocity triangle, okay. So velocity triangle, okay. Now this is your impeller blade, okay. Let me take, this is your impeller blade, okay, just a minute, that is your impeller blade, like this only, okay, that is your impeller blade, and from here that is your impeller blade, and from here here water is entering in the axial direction, okay, water is entering in the axial direction, so that will be your relative velocity and that will be your u1, okay, and that will be your alpha angle, inlet angle, okay, and v1, that is your alpha, so that will be your v1 is equal to vf1 because the entry of the liquid into the pump is axial, okay. Generally outlet velocity triangle is like this only, okay. So vf2 it is, vr2 it is equal to phi, it is equal to beta, okay, and that is your relative velocity and that is your that is your absolute velocity, and its component is VW2, okay, and that is your U, okay, that is your U2, okay, blade velocity at the outlet. But what is given to you, exit from the pump is radial with respect to impeller, okay, with respect to impeller. So phi is equal to 90 degrees. So what will be your velocity triangle at the outlet, velocity triangle at the outlet, that will be your V2, okay. So V2 and phi is equal to 90 degree, phi is equal to 90 degree, Vf2 is equal to Vr2, okay, and what we'll get here, Vw2 is equal to Vw2 is equal to U2, Vw2 is equal to U2. Are you getting this or not? So that is your velocity triangle for the given question, okay. And what is your Euler's equation of power? That is your m dot Vw2 U2 minus Vw1 U1. Yes or no? That is your Euler's equation. That is your Euler's equation. Now from here we can calculate m dot, okay, Vw2 U2, okay. So power and Vw1, that is your axial velocity. So velocity of work at the entrance will be equal to 0, okay. There is no mention of the velocity of work, okay. Vw1 is equal to 0. So m dot is m dot multiplied by Vw2 U2, okay, or m dot multiplied by U2 square, okay. Let me find out the U2 from the given data, okay. U2 is nothing but that is your pi d2n by 60, okay. So pi and diameter, radius is given to you, so radius is given to you, that is your 50 mm. So in meter, diameter 0.1 mm, and rpm is given to, that is your 3000 rpm divided by 60, divided by 60, okay. So 505 550 60, so 50 and 0.5 pi, okay. So U2 is equal to 5 pi. So P is equal to m dot, and power is given to you, that is a 2000 watt, m dot multiplied by 5 pi is square, okay. Now let you solve it for the m dot. What you'll get, 8.1057 meter per kilogram per second, okay. That will be your mass flow rate, that will be your mass flow rate asked in the kilogram per second, okay. So that will be your simple solution. Always go through the velocity triangle, okay, whatever is given to you, okay. Now after this, okay, so that will be your direction of the blade, okay. Thank you for now, okay. Water flows through two different pipes, A and B, of the same circular cross section but at different flow rates. The length of pipe A is 1 meter and the length of pipe B is 2 meter. The flow in both the pipes is laminar and fully developed, okay. If the frictional head loss occurs, the length of pipe is same, okay. The ratio of volume flow rate, that is your QB by QA, is round off to 2 decimal places, okay. So what is given to you, head loss, okay. What is given to you, that is your head loss, okay, in the both pipeline, in pipe A and pipe B. Pipe B, head loss are equal, means head loss at pipe A will be equal to head loss at pipe B, okay. So that is your nothing but head loss by the Hagen-Poiseuille equation. In the case of the full developed laminar flow, that is your 32 mu VL D square, okay, is equal to 32 mu VL divided by W D square in the pipe A and in the pipe B, okay, and same circular cross section means dia is same, okay, and water flow means same mu, okay, 32 density. What you will get? VA LA is equal to VB LB, okay, and the length are given, that is your 1 meter and 2 meter. So from here we can conclude that VB by VA is equal to 1 by 2, and discharge ratio they are asking for the discharge ratio, okay. So Q is equal to Q is equal to AV, okay, Q is equal to AV. From here let we go for the QB divided by QA, okay. So let we take QA, area of a VA, so QA is directly proportional to VA. Are you getting this or not? So QB by QA, QB is nothing but pi by 4 dB square multiplied by VB is VB, okay, pi by 4 d dA square multiplied by VA, okay, this will get cancel out. VB by VA is nothing but again 0.5, okay, so QB by QA is nothing but 0.5, okay. What I am saying, Q is directly proportional to A, okay, Q is directly proportional to A. So what will be your answer? That will be equal to 0.5 only, okay. Thank you for now. Next question. The aerodynamic drag on a sport car depends on its shape, okay. The car has a drag coefficient of 0.1 with the windows and roof closed. With the windows and roof open, the drag coefficient will become 0.8. The car travels at 44 km per hour with the windows and roof closed. For the same amount of power needed to overcome the aerodynamic drag, the speed of the car with the windows open and roof open, a round off to 2 decimal places, is dash 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 kilometer per hour. The density of air and the frontal area may be assumed constant, okay. Density of air and frontal area may be assumed constant, okay. So what is your aerodynamic drag force? Okay, it is nothing but half of CD rho AV square, okay. That is your force, that is your multiplied by velocity, okay. Let me take it is in the closed situation, first condition, where CD is given to you. For the CD at the closed condition, it is equal to 0.1 only, okay, it is equal to 0.1 only, okay. And for the roof and windows open, okay, half CD rho AV square multiplied by V, okay, that will be your that will be a when roof and windows are open, okay, roof and windows are open, where CD is given to you 0.8, okay. So there is no density variation and area variation, okay. Half will get also cancel out, so 0.1 multiplied by VCQ is equal to, that is your power, force multiplied by velocity, okay, force Newton meter per second, okay. So 0.8 multiplied by V open cube, 0.8 multiplied by V open cube, okay. Are you getting this or not? From here, what is given to you? When closed, 44 kilometer per hour, 44 kilometer per hour. So what now you have to calculate? That is your VO. So VO is nothing but cube root of VO is nothing but cube root of 0.1 multiplied by 44 cube divided by 0.8, okay. So let you calculate, you will get 22 kilometer per hour as an answer. Okay, when windows and roof are open, you have to drive your car at the 22 kilometer per hour for the 22 kilometer per hour for the same power. Okay, for the same power when your closed condition 44 kilometer per hour, but when it is open, because CD is more, so you have to drive your car when the windows and roof open, that is your 22 kilometer per hour. Okay, thank you.